Hello everyone, welcome back to my channel. Let's discuss this problem and try to find its solution. Now, in this question, we are given a reactant cis X which is getting converted into trans X. Now, this question basically belongs to chemical kinetics, specifically reversible first order kinetics. Here if you see, we are given the equilibrium constant 0.1 and Kf value. The Kf is the forward rate constant. Now, since this reaction is an equilibrium reaction, we will have both forward rate as well as backward rate. So, for each one, we have a rate constant, right? Let's say we'll assume that cis X is A and trans X is B. So, we'll write this reaction in the terms of A and B like this. At t is equal to 0, we have only pure cis form of A because it is mentioned in the question that we have only pure cis form. So, let's say t is equal to 0, we have A amount and B is 0. That means at any time t, A minus X, if X is the amount of A reacted, the amount of B formed is also X, and at any time t is equal to T equilibrium. Let's say when the equilibrium is achieved, then if Xc is the amount of A reacted, Xc is the amount of B formed, right? Now, we are given K equilibrium as 0.1. Since in this question only Kf is given and Kb is to be found, we can do one thing. We can apply the formula Kf is equal to Kf upon Kb. Since K equilibrium is 0.1 and Kf is 3 into 10 raised to the power minus 4, we can easily find the Kb, which is equal to 30 into 10 raised to the power minus 4, right? Since this reaction is a first order in both the directions, we can easily find the rate equation for first order of this equation. The equation comes out to be Kt equals 2.303 log of Xe upon Xe minus X. This is the equation of first order kinetics in the case of reversible reactions. Now here, one thing which is very much important is the rate constant K. This K rate constant is the net rate constant of this reaction, which is equal to Kf plus Kb. So that means whenever we solve the problems regarding the reversible order kinetics, always the net K will be equal to sum of forward rate constant as well as backward rate constant. So here this value comes out to be 3 into 10 raised to the power minus 4 plus 30 into 10 raised to the power minus 4, which is equal to 33 into 10 raised to the power minus 4. Right, so we have obtained the K, that is rate constant. Now, question is asking how long would it take for half of the equilibrium amount of trans isomer to be formed. That means question is asking from us that let's say at equilibrium the amount of trans isomer X, that is B, formed is Xe. That means in how much time the X formed will be equal to Xe by 2. Right, this is what is asked from us, that how long would it take for half of the equilibrium amount of the trans isomer to be formed. So the question is very simple now, we just needed to interpret what is given in it. Now we have to directly put the values, that means now K T is equal to 2.303 log of Xe will remain Xe upon Xe minus X. So X is given to us as Xe upon 2. So here the T comes out to be 2.303 upon 33 into 10 raised to the power minus 4 into log of, so if you solve this bracket part, it will come out to be 2, right? So 2.303 log 2 can be taken as 0.3 upon 33 into 10 raised to the power minus 4. If you solve it further, it will be 0.693 into 10 raised to the power 4 upon 33. Upon solving this part, this calculation, we will obtain the time to be 210. This is the value which we obtained in seconds, right? So the time comes out to be 210 seconds. That means after 210 seconds, the amount of trans isomer formed will be equal to half of the equilibrium amount which forms at T equilibrium. So the option D is correct. I hope you understand this question. For many such problems, stay tuned. Thank you.